All right. So let's start with that part there, right? So the first thing is we got 10 people in a group. Now I'm going to just jump into this, draw some kind of diagram, have it going there, right? Let's have a look at maybe something that looks like this. So we've got in a group of 10 people a $20, $10, and $5 prize. So we only have one $20 prize. We have one $10 prize and we have one $5 prize available. It says how many ways can the prizes be distributed to all of them? So in other words, we can start off with the 10 people, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're saying that if we want to put $20, let's say this guy gets 20, this one gets 10, this one gets 5. Or this one gets 20, this one gets 10, this one gets 5, or this one gets 20. And this will take forever, right? This will take forever because there's so many combinations there. But if we look at it, we have a total of 10 people. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people. So in other words, we could go backwards and say, okay, well, we got three spaces to fill. It's like first, second, and third. And how many ways can the prizes be distributed could possibly mean, okay, well, I've got 10 people that can get the first prize. And once it's gone, it's gone. And then one person is out. Now I've got 9 that can get the others, right? And then the other one. And then 8 for this one over here. So that means I have 10 ways, or 10 people can get that. And then 9, and then 8. And I would then multiply that, right? And if I multiply this will become 10 times 9, which is 90 times 8, which is 720. So this would be a permutation. This would be a permutation. And why would it be a permutation? Because a permutation, by definition, means it means that we basically have an arrangement where, especially the linear order of it, we're saying there's several possible options, and it's the number of ways you can order or arrange something. But we mustn't confuse it for a combination. So there's a definite order. Once one person has taken the first lead, then we remove them. And we have 9 left. Then we have 8 left. But we don't know these people individually. So we just see them as a group of 10. So we have 10 options. Yeah. We have 10 options, and then we have 9 options. And then we have, now, if I write it as a permutation, we would go 10 P3. And that would equal 10 factorial over 7 factorial. And that's the same as this, because that's going to be 10 times 9 times 8 times 7 until 1, divided by 7 times 6 times 5 times until 1. And so this whole second half of this will cancel out, leaving me with 10 times 9 times 8 for this one. Okay. All right. All right, let's go to another example now, right? Okay, so in the next example, we've got a group of, so in a group of 10 people, 3 $5 prizes will be given. How many ways can the prizes be distributed? Is the question. How many ways can the prizes be distributed? All right. So for this question here, what we have to, if you just jump in blindfolded and, or just logic, just use common logic. Got a group of 10 people again, and we have 3 prizes of the same value. So we have 1, 2, 3. 3 $5 prizes will be given. How many ways can the prizes be distributed? So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people. We want to fit the three prizes in the 10 people somehow. And in this way here, we're saying that if we do it like previously, the first prize, right? The first prize, there's 10 options. So if we go back to the previous idea where we have a person in each case, right? I'm just going to get creative and draw this quickly. All right, so I got these 10 people, and there are 10 ways of getting the first prize. So the first prize comes up. Okay, winner, remove him, remove the prize. Next person, randomly one of the 9, come up. So there's 10 ways there, 9 ways there, and then 8 ways after that. And we just keep removing until the prizes are finished. But now, the problem with this, the difference between this question and the previous one, well, not the problem, but the difference is here the prizes are different. Here the prizes are all the same. They're each going to be $5. So because each of these prizes are $5, after we've calculated this, which is 720, we need to remove all the possible ways of arranging the $5. In other words, because there's going to be a repeated, the prizes are the same, right? So it says how many ways can the prizes be distributed. So in this case here, what we're actually doing is using a combination. Using a combination for this. Okay. So let's go through. So with a combination, you're basically going to have 10, choose 3, right? So we're giving out 3 prizes to 10 people. And it's similar to a permutation. That's the permutation part. But at the same time, we have to divide it by the total number of possible combinations of arranging the $5 so that we can remove it. Whenever we divide, it's almost like we're removing repetition. Okay, so we divide out all the counted things twice. So we need to divide out the 3 factorial from here, which is equal to 6 ways of counting things twice, so that you're left with 120 after that. Okay, so this over here is going to be basically 3 factorial. 720 over 3 factorial. All right. Now, when you write this out, what you can do is look. All right. So, a school board with 8 people needs to form a committee. How many ways can this be formed? All right, let's look at it. So, 8 people, 2, 3, 4, 5, 6, 7, 8. And we want to fit 3 people. How many ways? So, school board with 8 people. So, they are 8 people. Actually, they are 8 people. So, let's go back again. So, there's 1, 2 different people, 4, 5, 6, 7, 8 people. And the committee has only 3 spots. So local board with 8 people needs to form a committee with 3 people. How many ways can this be formed? So if I put one person in here, I have 10 ways of doing that. And let's say it's this person. I then remove that person. And then I have 9 ways over here. And then I remove that person, whichever person it was. And then I have 8 ways over here. And so I have 10 times 9 times 8, which is 90 times 8, which is 720 ways of putting 10 people in 3 possible spots, right? But now the question comes in when I do this is the following. What happens if this person who is number 1 and this one is number 2 and this is number 3 ends up the other way? So this goes here. Is that a different committee? No, it's exactly the same, right? So here we are repeating. We've got the same committee, we just chose him at different points. We chose the third guy first, the second guy, etc., etc. And so we can arrange 1, 2, and 3 in how many ways? So we can go 1, 3, 2, 1 is done, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. And so we got 6 ways of arranging that. So we would then take that 720 and let's say we divide it by 6 factorial. I mean 6. That means there'll be 120 possible ways to do this. All right. Now, how do we write this? And if we had to write this, what will it come to? What will the total come to in terms of putting it on a calculator? Would we use a combination? Would we use a permutation? Right? And that's the question here. 8 people. If I go 8, choose 3, what does this mean? This means 8 factorial over 3 factorial times 5 factorial. And that's 8 times 3 times 2 times 1. 8 times 7 times 6 times 5 times etc. until 1. And then we've got 5 times 3 times until 1. And then 3 times 2 times 1. And you can see all of that will cancel. And so we end up with 8 times 7 times 6, which is going to be not what I had here because this is 10 people. So this won't be 720. This is supposed to be 8 times 7 times 6. 8 times 7 is going to get me 56. And what is 56 times 6? So let's get 56 times 6. 6 times 6 is 36. 6 times 5 is 30 plus 3 is 33. So that's 336 ways. 336 ways divided by 6 ways after that. All right. How do we end up writing this? We end up writing this as 8 times 7 times 6, all the way backwards there. So let's just start again quickly. We have 8 people, not 10. Okay. So that's going to be one more there. Oh, that was 8. All right. So here we're going to have 8 times 7 times 6. But we can arrange this in 3 factorial ways. So we take whatever number that is and we divide it in. Okay, so divided by 3 factorial, which is going to be the same as 6. And then we get 336 divided by 6. Okay. And we put that on the calculator. So for this one here, 336 divided by 6 will come to 56. So there's 56 ways that this would happen. This would be 8C3, which is 8 factorial over 3 factorial, 5 factorial. You can put that on a calculator as well. You press 8, shift, press the C button, 3, and it will come to 56 as well. Okay, but having a look at it just manually like that, that's what it would be for that. Okay, so a local school board with 8 people, again, need to form a committee. So we've got 8 people. 1, 2, 3, 4, 5, 6, 7, 8 people. Need to form a committee with 3 people. If 5 of the members are girls, 2, 3, 4, 5, and 3 of the members are boys, how many ways can the committee be formed if 2 must be girls and 1 must be a boy? So what we notice here is that we have a total of 5 girls and we have 2 spots to choose. So if we had to put this in here, we would say 5 choose 2. and then three boys choose one. To get that spot, we go three, choose one from there. So five, choose two would go in there, and we would then multiply these two together. Five, choose two times three, choose one. And that would get me the answer, which will, once we put it on a calculator, come to 30. Okay, let's look at this from a logical space. What does this actually mean in terms of combination broken down manually? Firstly, we have five options of choosing the first go. Once we've chosen them, we have four options left of choosing the second go. From the boys, we have three options over there. That's it. Now remember, these two are interchangeable. If girl one goes here and girl two goes there, girl two could go here and girl one could go there. So we have a repeated option where we're going to have one, two, and let's say specific numbers. Let's say specific first people are chosen. So let's say 1G got chosen, 2G got chosen, and 7B got chosen. We can arrange this as 2, 1, 7 as well, right? Where it's also girl, girl, boy. And so here we remove that repetition by dividing it by 2 because there's two options. So how do we know to divide by 2? Because we can arrange these two in two factorial ways. So if I go 1, 2, and 7, this over here, we have 5 options, then 4 options after we've chosen those two. But at the same time, we have to divide it by 2 factorial because 2 factorial is the number of ways of arranging those two because the committee will still be the same. And this one, there's 3 options available. So we put just 3 there. And so we end up with 5 times 4 is 20 times 3 is 60 over 2, which is equal to 30. And that would be the logical approach of just thinking about it. In terms of combinations, it comes to the same answer using 5 choose 2 and 3 choose 1. In how many ways, now, next question, can in how many ways a committee consisting of 5 men and 3 women can be chosen from 9 men and 12 women? Okay, so let's write this down. Committee consisting of 5 men. Okay. And can be chosen from 9 men. Oh, 5 men and 3 women. And there's 9 men to choose from. 5, 6, 7, 8, 9. And there's 12 women. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 women. We want to choose that from the men, and we would choose that from the women. So, the first thing is remember the first man, we have how many options? We have 9 options. Then we've chosen him. The next one, 8 options, 7, 6, and then 5. 8, 7, 6, and then 5 options available. With the woman, it's exactly the same thing. It's going to be a total of 12 women in the first option, then 11, then 10. And there we start. All right. But now we're going to keep multiplying these across. But now we have to remember that if I chose this man over there in the first round, and then I chose him in the possibility in there, possibility in there, possibility in there, I have to arrange this and remove as many of those arrangements where we're repeating the same thing. So M1, 2, 3, 4, 5 can be 2, 1, 3, 4, 5 can be 3, 1, 2. So what are we actually arranging here? 5 factorial ways. And so we want to divide this by 5 factorial. And over here, we can arrange this in 3 factorial ways. So we're going to divide it by 3 factorial. And if we do that, what will that come to? So I put this on the calculator manually. I'm going to go into the calculator manually, and I'm going to go 9 times 8 times 7 times 6 times 5. Comes to 15,120. And 5 factorial is 120. So 5120 divided by 120 divided by 120 is 126 ways. So this will happen in 126 ways. Then we've got 12 times 11 times 10, which is 1,320 divided by 3 times 2, which is going to be 6. 3 factorial is 6. And so we divide it by 6, comes to 220. And then we multiply those two. So 126 times 220 is 27,720. Now, if I use a combination, this should go faster, right? That means if I had to go 9C5 times 12C3, let's put that on a calculator. 9 choose 5 times 12 choose 3. 9 choose 5 times 12 choose 3. Comes to the same answer. 27,720 different ways. But the actual combination doesn't show you the detail that I'm showing you here. You just got to understand this is what's happening, and that's the quick way of doing it. Okay.